Welcome back, guys. Today I'll be doing implicit differentiation. Let's get started. Here I'm going to differentiate the following. Wherever I see y, I am going to put dy dx when I'm differentiating. But first, I'll carry the x squared over the equal sign, so I'll have everything on my left. Then I start to differentiate. So this becomes minus x squared, and then I have equals 0. Now differentiating the variable y, what's going to happen is that I differentiate y to get 1, but because it's a y variable and I'm differentiating with respect to x, that's why we put dy over dx. The x variable that I'm going to differentiate is just going to give me a 1 and I have the minus sign. Differentiate a constant, that's 0, and differentiate x squared, that's going to be 2x. Now, I need to make dy dx be the subject. So 1 times dy over dx gives me dy over dx. I have a minus 1 minus 2x equals 0. I need to carry anything that doesn't have dy dx attached to it. I carry it over to my right. So what I have is dy over dx is equal to positive 1 plus 2x. And now I have the derivative. Now let's look at another activity. Now, here I have another activity where I have two things, which is two terms, on my right hand side, and I am going to carry it over to my left. So I need to carry everything over to the left, but what I'm going to do is just group the y's together. So we're going to have y squared minus y cubed minus 3x, and then it's going to be plus 5x squared, because once it goes over the equal sign, there's a sign change. Now, once again, differentiating a y variable with respect to x, I will have to differentiate y squared to get 2y, but I attach dy over dx. So it's the same scenario with minus y cubed. I differentiate this to get minus 3y squared. And then I attach dy over dx. The remaining x variable, I have minus 3x, differentiate that to get minus 3, and differentiate 5x squared to get 10x equals 0. Now, after doing this, I'm going to carry the ones without dy dx over to my right, while the remaining, I will have to factor out dy over dx. That's common. That's the only thing I want to factor out, although we have y that's common. But before I do the factoring out, let's just carry over minus 3 and plus 10x over the equal sign. So I am going to have positive 3 because there's a sign change. So we have positive 3 and the plus 10x become minus 10x. Now this is where I will factor out dy over dx. So what is remaining inside the bracket? It is 2y minus 3y squared. Now what I am going to do is write the remaining, which is equal 3 minus 10x. And the next step for me is to divide both sides by the 2y minus 3y squared. So when I divide both sides by 2y minus 3y squared, these will cancel on the left. So I'll have this being cancelled, and I'm left with dy over dx equal the fraction on the right, and that will be my derivative. Now, my next example, there are times when we have product of x variable and y variable, and we have to use product rule to differentiate when you have a product of two variables. So in this case, I have xy squared. So using product rule, I assigned x to be u and y squared to be v. So it means I will have to differentiate x to get 1, that would be u prime, and differentiate y squared to be 2y, but I need to attach dy over dx because it's a y variable. So we have dy over dx. Now, product rule, so it's u times v prime. So I'll have x times 2y dy over dx plus u prime times v, so that would be 1 times y squared. I'm going to write 1 times y squared. Next, differentiate the rest ordinary, minus 3x. Differentiate this to get minus 3, and a constant gives us 0 equals 0. So simplifying what I have x times 2y, that's 2xy, then I have my dy dx attached to this, so dy over dx. And then 1 times y squared, that's y squared, minus 3. So y squared and minus 3 doesn't have dy over dx, so I will carry them over to my right hand side and leave 2xy dy over dx on my left. So having this, I will have minus y squared plus 3. So minus y squared plus 3. And then I divide both sides by 2xy. When I divide both sides by 2xy, these cancel. So I have dy over dx is equal to minus y squared plus 3 divided by 2xy. And this is my derivative. Now I'm going to do another one where I will need product rule. So let me go ahead and write this. I have x cubed y squared. So it's a product of two functions. That's why we use product rule here. Minus 3y squared minus 5x equal 7x squared. Once again, I need to carry the 7x squared over the equal sign. So what do I have? I have x cubed y squared minus 3y squared minus 5x minus 7x squared equals 0. And now differentiating this using product rule, this is u and v. So u prime, I will differentiate x cubed to get 3x squared. But I will now differentiate y squared because it's a y variable. I differentiate this to get 2y, but I attach dy over dx to this. Applying u times v prime, I will have x cubed times 2y dy over dx. That's u times v prime. Next, I'm going to have plus u prime times v, so that's y squared times 3x squared. So that's 3x squared times y squared. Now differentiate minus 3y squared, it will be minus 6y, but then I'll have dy over dx because it's a y variable. And I'm differentiating with respect to x. Differentiate minus 5x, so I'll have minus 5, and differentiate minus 7x squared, that would be 14x equal 0. Now looking at this, I can carry over the ones that don't have dy over dx over to my right hand side, while the ones that have dy dx, I'll write them together. So x cubed times 2y, that's 2x cubed y. Then I have dy over dx minus 6y dy dx. So that's this, 6y dy over dx equal, carry this over, so it's going to be minus 3x squared y squared. So minus 3x squared y squared. This becomes plus 5 and plus 14x. The next step, I am going to go ahead and factor out dy over dx. So when I factor out dy over dx, I'm left with 2x cubed y minus 6y is equal to minus 3x squared y squared plus 5 plus 14x. Now I'm going to divide both sides by 2x cubed y minus 6y. So I have 2x cubed y minus 6y. Divide both sides by 2x cubed y minus 6y. This cancels, so I'm left with dy over dx is equal to the fraction that I have on the right, and this represents the derivative. And that's it. Just don't forget to like and subscribe to my channel. Have a great day.